been one of the most radical ideas in computer science. It is where the concept of a laptop came from, a personal computer. It is where object-oriented programming came from. It is where model view controller came from. The whole goal of model view controller is to take this model that is in the code and to display it on the screen as something called a view. And that allows me, as the user, to connect with the other part of my brain that is sitting in here so that the two are in sync. The model is put on the screen as a view. And then there's this thing called the controller that creates views and coordinates them. This is a pattern language. It's a pattern language called Model View Controller. Now these days, Trygve is the inventor of Model View Controller. He and I have been calling it Model View Controller User. The user is the forgotten object and the most important one. And that's a very important part of the architecture. Here's a quote. On the other hand, people need a chance to identify with the part of the environment in which they live and work. They want some sense of ownership, some sense of territory. The most vital question about the various places in any community is always this: do the people who use them own them psychologically? Do they feel that they can do with them as they wish? Do they feel that the place is theirs? Are they free to make the place their own? Who is this? Oh, this is Christopher Alexander again. Oh, these are patterns. So here again we have a pattern principle of this end user involvement, this community involvement. In DCI, we're working with the end user's mental model. And in the process of building a lean architecture, we're engaging the end user. And this is an agile principle of engaging our end users as part of the process to get continuous feedback. So when we build a system, we will build a system of lots of objects. So here we have objects. This is how the user may think of the program in their head. Oh, there's my savings account, there's my checking account, there's my investment account. These are things I have in my head. And now I want to do a withdrawal. I want to withdraw money. Well, that is a use case. And it will connect together these objects in a certain way. And now I want to do a deposit. That is another use case. That also is in my mental model, and that will connect together another set of objects. And now I want to do a money transfer, and that is another use case, another set of objects. Oh, what are these? These are patterns. I can draw them. I have a picture of them. They reflect my model of what's going on. So all I need to do for money transfer is say, well, this object first, then that object second, then that object third, then that one, right? Well, not quite, because the next time it may look like this. So what is common and what varies? What is common is the form. Form is common. The actual structure that implements the form changes. Because now I'm using this object instead of this one in order to implement that part of the use case. We have a word for capturing form. It is called architecture. And these are patterns in architecture. What we need to do is treat them as patterns in their own right. So we're going to pull these out of the code. There's my money transfer, there's my money withdrawal, and there's my money deposit. And each one of these is a solution to a problem. in what is called a context. Now, what's scary here is context is not my word, and it was not stolen from Alexander. This is actually Trygve-Ringskog's word for these collection of roles that interact. So there's the context for one use case. Here's the context for another. And so I now have a place in the code called a context. And these things are called roles. And I'm going to be writing code for roles. And the roles in a context will be what the system does. The objects are what the system is. Now, I gave a talk about this last night, and there's a lot of other important things here that are a little bit shocking. These are objects. How many of you write objects when you write code? How many of you write objects? Not classes, objects. We are not doing object-oriented programming. We are doing class-oriented programming, and they are very, very different. And what your professors have been telling you for 40 years is object-oriented programming is class-oriented programming. It'd be like Alexander saying, let's do pre-manufactured houses. We'll have this class of bathrooms and this class of living rooms. It's kind of like Jon Utzon. You looked at Utsson's architecture from Denmark? Alexander hates pre-manufactured parts. They should be tailored piece by piece. So these things are pictures, drawings of the use cases. And here is an amazing quote. And finally, of course, I want to paint a picture which allows me to understand the patterns of events which keep on happening in the thing whose structure I seek. In other words, I hope to find a picture or a structure which will, in some rather obvious and simple sense, account for the outward properties for the pattern of events of the thing which I am studying. So, Nakano-san, this has always been one of the most puzzling parts of the nature of Thomas' way of building to me. And I always wondered if Alexander understood time. He understands space very, very well. But I always wondered if he understands time. And this is kind of as close as he comes. I now understand perfectly what this means in software. I need your help in understanding now more perfectly what this means in the built world, because I thought I understood, and now I am not sure that I do. What are these patterns of events? Are your patterns of events? Function has form. A good, agile architecture that engages the end user has the form of function. What are these? These are patterns that honor the fact that we value the human's mental model, that we value experience, things that are stable. So now we are back to the pattern value system in building product. There's always a human element. We always have the human's mental model. We have local symmetry breaking. We have use cases into methods and businesses into roles. We're building systems by compositions. We're going to compose classes together. We're going to compose the use case with the domain class in order to build a system. That's how patterns work, is by composition. We have a single general overall form. And like a pattern language, it can be implemented a million different ways without ever being the same twice. So some quick slides on symmetry breaking. I said earlier that phone call is not an object because parts of it have to live in two different cities. So what the pattern people said, and this is Gerard Mazaros, who wrote a